Ever stop to think about this? You've got a solar panel soaking up the sun, or maybe a big car battery. But how does that actually power your TV or your laptop? I mean, they're speaking two totally different electrical languages. Well, today we're going to talk about the amazing little translator that makes it all work. It's called an inverter.
Okay, so think about it like this. The power from a battery, it's like a calm, steady river, just flowing in one direction. Easy. But the power from your wall socket? Ooh, that's more like a wild ocean tide, rushing in and out, back and forth, over and over again. They couldn't be more different, right? So the big question is, how on earth do we bridge that gap to make battery power useful in our homes?
And that brings us to the hero of our story today, the inverter. Its whole job, its entire purpose in life, is to step in and solve this exact problem. It takes that calm, one-way street of power, we call that direct current, or DC, and it masterfully converts it into that back-and-forth powerhouse stuff, which we call alternating current, or AC. It's literally the translator between those two electrical languages we were just talking about.
So, to really get why inverters are so cool and so important, we got to quickly dive into this tale of two currents. Let's break down DC and AC a little bit more.
All right, so first up, you've got direct current, DC. Super simple. It's a constant, steady flow, always going in the same direction. The water through a hose analogy is perfect. And that's exactly what you get from batteries and solar panels. Then you've got the other kind, alternating current, AC. This one's the wild one. It's constantly flipping its direction, about 60 times every second here in the US. And that's the juice that comes out of every wall socket in your house. Okay, now that we've got the basics down, let's jump into the most common type of inverter you'll ever run into. This is the single-phase inverter. It's the absolute workhorse of the inverter world, powering everything from your home solar system to those portable power stations you take camping. So, to really wrap our heads around how these things tick, we're going to look at a couple of examples. Now, these are actually inspired by some pretty heavy-duty power electronics problems from a textbook, but don't worry, we're skipping all the scary math. We're just here for the cool concepts. All right, for our first case, let's imagine we've got an 80-volt DC input. This could be coming from a decent-sized battery bank or maybe a small solar setup on an RV. The inverter's job, its big challenge, is to take that steady, unwavering 80 volts and somehow make it dance, make it alternate. So how in the world does it do that? Well, the best way to think about it is like a ridiculously fast electronic switch. It's just flipping the flow of that DC current back and forth, so fast you can't even see it. And by doing that, it creates this single, smooth, alternating wave of power that looks a whole lot like the AC you get from the power company. Now, engineers have a couple of main ways to build this super fast switch. You'll hear terms like half-bridge and full-bridge. The only thing you really need to remember is this. Half-bridge is the simpler, more basic design. Full-bridge is a bit more complex, but the payoff is that you get much cleaner, higher quality power out of it. Okay, so single-phase is great for everyday stuff. But what about the really big jobs? Sometimes one single wave of AC power just isn't going to cut it. And that's where we have to level up. We need to bring in the industrial powerhouse, the three-phase inverter. And believe me, the jump in scale here is huge. Our next example, we're not talking 80 volts anymore. We're leaping all the way up to a 600-volt DC source. Yeah, this is not for your little portable power pack. We are talking serious, heavy-duty, industrial-level stuff now. Which kind of begs the question, right? If the single-phase inverter works just fine, why bother with all the extra complexity of creating three phases? What's the big advantage here? Well, the logic behind it is actually pretty brilliant. A three-phase inverter takes that big, beefy DC input, like our 600 volts, and instead of making one wave, it creates three separate AC waves. And the secret sauce is that they're all slightly out of sync with each other. The result? You get this incredibly smooth, constant delivery of power. It's like having three people pushing a merry-go-round instead of one. As one person's push is ending, another's is just beginning. There are no dead spots, no gaps in power like you'd get with just a single wave. So, what's the bottom line? More power and way more stability. This is absolutely critical for things like massive industrial motors, for powering huge data centers, or for feeding power back into the main electrical grid. These are all places where a stable, reliable power supply isn't just nice to have, it's everything. Okay, so that's the theory. We've talked single-phase, we've talked three-phase, but where do you actually bump into these things in the real world? Let's take a look. It really all comes down to power needs. Think of it this way. Single-phase inverters, that's for our personal world. Your home, solar system, the little brick that charges your laptop, those portable power packs, anything with a lower power demand. But three-phase inverters, that's the backbone of industry. We're talking factory motors, the servers and data centers, and massive grid-scale renewable energy farms.
All right, so let's wrap this up. What have we learned? An inverter's main gig is to turn DC power into AC power. Simple as that. The single-phase kind is for all our daily gadgets and smaller setups. The beefy three-phase version is for the big industrial jobs. At the end of the day, the one you choose just depends on how much power you need and how rock-solid that power has to be.
And that leaves us with a pretty cool thought to chew on. As we shift more and more towards renewable energy, think about it. Solar panels, they produce DC power. Batteries, they store DC power. Our entire energy future is basically being built on a foundation of DC. And what does that mean? It means the humble inverter, this little electronic translator, is becoming more important than ever before. It is literally the bridge connecting the power of tomorrow with the world we live in today. Thanks for tuning in.